Okay, so let's put together our simulation for the metal. So let's call this metal sim. Okay, dive inside, object merge, and I'm going to go ahead and find that big metal, the big metal. So not the pre-fracture, just the big metal, and we're not going to be simulating the small metal in this simulation. We'll leave that for the second one. And then we'll also just alt click and drag just to make another one of these, and then go ahead and find the collider as well. Grab that. So yeah, just to explain about how to, you know, decide what you're going to simulate at which points. The way to think about it is, you know, what's going to have the most effect on your sim. So for example, glass. If a piece of glass falls into the metal's probably not going to move. But if the metal hits a piece of glass, then the glass is going to move. It's like which, you know, do the denser, heavier, stronger materials first, and then things lighter, smaller things later. So glass and wood I'll do in the next simulation, and the small pieces of metal, even though they're metal, they're only small, so they don't have a lot of inertia behind them, right? So I'm gonna excuse me, simulate this metal, and then just use that as a collider for the next simulation, right? So this is packed at the moment. You can tell just by looking at it, and then when you go to select it, you can see it's just one thing. We just got the one point in the middle. So we just grab RBD unpack. Make sure you use RBD unpack, not just the unpack. That way we get the constraints and everything separately here. Okay, and then we need to start setting up our constraints here. So I'm going to build some constraints first, some more. So I'm going to use RBD constraints from rules. Just for connecting these as well, if I remember correctly, one way, what I normally do is before you click, see it's kind of there. If you go close, you can see them kind of join up. So you can do that. You can also, I think if you click on one and then hold shift, click on the next, and then I'm still holding shift, and then go to one, click and release, and then it connects them up for you. Could save a bit of time. So constraints from rules. So this is going to build some new constraints for us, and at the moment it's just placing them everywhere between any thing which has a different name, right? So I don't want that. I wanted to build pieces between, because at the moment we don't have any constraints between the separate kind of sections of our geometry, right? So if you remember, we made that class attribute and the section one, but I'm going to use the class one here, and you can see what that does. When I put the piece attribute to class, it's going to put constraints between pieces which have different values for class. So they're making, it's almost like the glue between, say, well, you can see here connectors, right, between everything. So that looks okay. I'm going to bring this down. Just give me a few. We don't need so many constraints. And then I'm going to call this connectors. This will be a name for the group. Call this metal. So they're connecting metal to metal. I know it's kind of strange in this case, but it's just my convention of what I do. You know, in the next simulation, we'll have metal to glass and wood to metal, wood to wood. So it's just my, you know, my habit of doing it like this. So that's fine. Now the constraint properties. So at the moment we don't have any values on the constraint properties, so the simulation won't work. Okay, we need to actually give them a name and a type, and a, you know, a strength if we're using glue and so forth. Okay, so we'll use the same for both. So we'll be doing, oops. So this will be on the, well, actually I won't put a group because I want this to affect the constraints between these pieces and, you know, all of the constraints that we've got. So we're going to start with glue. I'm going to give it a pretty weak strength. Okay, and that's because all this glue is doing is holding the object up. All I wanted to do is stop the object from collapsing under its own weight. And then because we're going to be switching to a soft constraint after, okay, so as soon as it breaks, any force is applied to it, I want it to switch to a soft constraint, which will allow these to bend and curve and behave like a metal, right? Which is, you know, metal is malleable, it bends and flexes, it doesn't snap, okay? So it's important that we have this glue, these soft constraints as well. I'm also gonna push up these propagation iterations. So this is how often the solver calculates the kind of spread of the impact. So if we have an impact here, right, if we have this set to 0, then you know, these pieces will break and nothing else will break. And then the higher I push this up, the further out this that impact will have an effect. And obviously with metal, if you imagine something hitting here, it's not just going to have one perfect kind of U bend, it's going to have an effect over the whole thing. So that's why I'm pushing this all the way up to 10. So we're going to have soft constraints. I want them to be very stiff. Metal is very strong. And damping ratio, we'll leave it as it is. We're going to override the angular stiffness and damping ratio. So with the soft constraints, we can affect the, you know, it's moving away from another piece and also rotating. So I want to make that also very strong, and I'm going to have the angular damping to 10. So the damping is to stop it kind of springing too much. It's going to spring a little, you know, it is metal, but I don't want it to be really wobbly and bouncy, because, you know, that might be a bit more like plastic, for example. Now, as it is now, if we fracture this, it's going to try and hold the shape that it's in now. So it will break and then it will try and return to this shape that it's in now. But what we want is something new. I think it's new in Houdini 18, which is called plasticity. We've had it in vellum since 17, I think. But now we've got it in RBD and we can use it with metal, which is great. And what that means is that when a soft constraint is the rest position, so either the length or the pivot, you know, if it's rotated, it's going to try and hold that new position based on these values, right? So we have the angular plasticity, which is for the bending, the turning, which is important for us, and also the stretch plasticity, okay? And we have the rate, which is how quickly it will try to, how quickly it will apply that new rest position, and also the hardening. So you know, how stiff will it be at the end. So I'm just going to push all these to 10, right? And then the threshold, so at when the distance is changed by 0.05, then it will start to apply the plasticity. And then if this in degrees, yeah, so once it's bent by 10 degrees, it will start to apply it. But I want it quicker than that, just after 1 degree, so it's, you know, trying to bend it very, very quickly. Okay, cool. So that's all of our, so we've got our new constraints. Maybe we can name this. Well, we can see it here, actually. We don't need to name it. And then constraint properties here, this is for all of the constraints. So that's good. Yeah, I'll leave it to the next video for actually simulating this.